Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So before I go ahead and teach you actually how we can actually go ahead and hack into something, I'd like to teach you about one final thing before that, and that is 802.1x. Understanding what the IEEE 802.1x standard is and why you should care means understanding three different concepts which I will be teaching you today, that is PPP, EAP and 802.1x itself. So understanding what IEEE 802.1x understand, I'll go and teach you exactly what that means today. So most people are familiar with PPP, that's point-to-point protocol. PPP is, or I'll call it as PCube as of now because that's quite easy than going ahead and spelling it out as PPP or pronouncing it PPP, whatever. So PPP is most commonly used, or PCube is most commonly used for dial-up internet access. PCube is also used by some ISP for DSL and cable modem authentication in form of PCube over Ethernet. So PCube is a part of layer 2 tunneling protocol that is a core part of Microsoft's secure remote access solution for Windows 2000 and after that. PCube evolved beyond its original use as a dial-up access method and is now used all over the internet. One piece of PCube defines an authentication mechanism. With dial-up internet access, that's the username and password you're using. PCube authentication is used to identify the user at the other end of the PCube line before giving them access. Most enterprises want to do more for security than simply employing username and passwords for access. So a new authentication protocol called the Extensible Authentication Protocol, that's EAP, it was designed. EAP sits inside the PPP's authentication protocol and provides a generalized framework for several different authentication methods. EAP is supposed to head off proprietary authentication systems and let everything from password to challenge response tokens and public key infrastructure certificates all work smoothly. So with a standardized EAP, interoperability and compatibility of authentication methods become very simpler. For example, when you dial a remote access server and use the EAP as part of your PPP connection, the RAS doesn't need to know any of the details about the authentication system, and only you and the authentication server have to be coordinated. By supporting EAP authentication, as a RAS server gets out of the business of acting as middleman and just packets and repackages EAP packets to hand off to a Radius server that will do the actual authentication. So this brings us to the IEEE 802.1x standard, which is simply a standard for passing EAP over a wired or wireless LAN. With 802.1x, your package EAP messages in Ethernet frames and it does not use PPP. Its authentication needs much more. That's desirable in situations in which rest of the PCube isn't needed when you're using protocols other than the TCP/IP, or where the overhead and the complexity of PPP is undesirable. But 802.1x uses three terms that you need to know. The user or client that wants to be authenticated is called as a supplicant. The actual server doing the authentication, typically a Radius server, which is called the authentication server, and the device in between, such as a wireless access point. It is also called as the authenticator. One of the key points of 802.1x is that authenticator can be simple and dumb, and all of the brains have to be, let's say, in the supplicant and the authentication server, similar to like computer. Your monitor is just deaf and dumb and it does all the work that your computer does, that your CPU does. So this makes 802.1x ideal for wireless access points, which are typically small and have little memory and processing power. So the protocol in 802.1x is called EAP encapsulation over LANs, that's EAPOL. And it is currently defined for Ethernet-like LANs, including 802.11 wireless as well, and along with that, as well as the token ring LANs such as FDDI. And EPOL is not particularly sophisticated. There are number of modes of operation, but the most common case would look something like the authenticator sends an EAP request identify packet to the supplicant, and you can say, as let's say, as soon as it detects that the link is active, it will go ahead and send the packet. The supplicant sends an EAP response identity packet to the authenticator, which is then passed on to the authentication server, that's Radius. And the authentication server sends back a challenge to the authenticator, such as with the token password system. The authenticator then unpacks this from the IP, that's Internet Protocol, and repackages it into EAPOL. That's again what I told you previously. That's EPOL, that's EAP encapsulation over LAN. And then it sends it back to the supplicant. So different authentication methods will vary this message and total number of messages. EAP supports client-only authentication and strong mutual authentication. Only strong mutual authentication is considered appropriate for the wireless case. And to be more specific, in the end, if the supplicant provides proper identity, the supplicant responds to the challenge via authenticator and passes the response onto the authentication server. Supplicant provides proper identity, the authentication server responds with a success message, which is then passed on to the supplicant. The authenticator now allows the LAN, possibly restricted based on the attributes that came back from the authentication server. To be more specific, let's say the authenticator might switch these supplicant to a particular virtual LAN or install a set of firewall rules. So you might be wondering that how does the 802.1x help wireless security? So it's so complicated. The 13-year-old wired equivalent policy, that's WEP protocol, it has been discredited so thoroughly that its authentication and encryption capabilities are not considered sufficient for use in enterprise networks. In response to the WEP fiasco, many wireless LAN vendors have latched onto IEEE 802.1x standard to help authenticate and secure both wireless and wired LANs. The wildcard with 802.1x protocol is interoperability. So 802.1x authentication might it helps mitigate, you can say, as many of the risks involved in using WEP. For example, one of the biggest problems with WEP is the long life of keys and the fact that they are shared among users and are very well known. With 802.1x, each station could have a unique WEP key for every session. The authenticator, that's wireless access point, could also choose to change the WEP key very frequently, such as even every 10 minutes or every 1000 frames. So the 802.1x does not guarantee improved security. For example, an authenticator might never change the key it hands out to each supplement, or the network manager might select an authentication method that does not allow for distribution of WEP keys. So 802.1x does, however, give the informed network manager the potential to design and implement a more secure wireless LAN. So this is how it works in total. It's not always how much secure you can keep. It's more about how much you can go ahead and complicate it so that it becomes more complicated for the attacker to go ahead and hack, and he will simply go ahead and lose his trust in hacking, and he will probably may not, or leave that part and try something else. And at least your wireless security will be secure. So Wi-Fi, and just to be sure, Wi-Fi cracking is not for beginners, and playing it with it requires basic knowledge of how WPA authentication works and moderate familiarity with Kali Linux and its tool. So if any hacker at any point of time gains access to your network, he is probably no beginner, because no one can go ahead and crack a Wi-Fi that's a WPA2 password by mistake, unless until he does some kind of social engineering, in which case he's again very good, and again you are at loss. So that is it, and that's the end for my theoretical part for the WPA and the wireless security keys. In this tutorial, I'll be actually teaching you as to how we can go ahead and hack into some network using Kali Linux.